Example. A 6 inches I-beam is located 28 from a box. Using 30 degrees bends, layout bend marks A and B, as shown in figure 7 to 26. Total shrink value is found by multiplying height of the offset, 6 inches, times the 30 degrees shrink value, 1/4 per inch of rise. Total shrink equals 6 inches by 1/4, equals 6/4 or 1½ of shrink. Add the total shrink of 1½ to the 28 inches distance from the box to the obstruction to locate bend mark A28, plus 1½ equals 29½ Measure 29½ from the end of the conduit and mark bend mark A is shown in figure 7 to 27. Spacing between bend mark A and B is found by multiplying the 30 degrees offset multiplier 2.0 times the 6 inches height of the obstruction. 2 by 6 equals 12 inches spacing between A and B, as shown in figure 7 to 27. Example. A conduit is to be bent as indicated in figure 7 to 28, using 45 degrees bends for the offset, layout bend marks A and B. 1. Determine total shrink by multiplying the height of the obstruction, 10, times the shrink value for 45 degrees offsets, per inch of rise as shown in table 7 to 21. 10 inches by 3/8 equals 38 or 3 3/4 of total shrink. 2. Add the total shrink to the distance from the box to the obstruction. 3 3/4 plus 48 equals 51 3/4. 3. Measure 51 3/4 from the end of the conduit and mark bend mark A, as shown in figure 7 to 29. 4. Multiply the height of the offset, 10, times the 45 degrees offset multiplier, 1.414, to determine the spacing between bend marks A and B. 10 inches by 1.414 equals 14 1/4. As this is the measurement that will determine the height of the obstruction, 14.14, will be rounded up to the next, for a measurement of 14 1/4. 5. Measure 14 1/4, from bend mark A and mark bend mark B, as shown in figure 7 to 29. Remember to turn your back on the end of the conduit that the measurements were taken from when bending at bend mark A and B problems. Layout pipe to bend as indicated using method number 2. Parallel offsets 8. Figure 8 to 1 shows 3 pipes, each with a 10 inches offset. All 3 pipes were bent using the same layout, and the offset were bent using 45 degrees bends. When the pipes are mounted and spaced at 2 inches intervals, the spacing looks great, but the ends of the conduits end up staggered. Figure 8 to 2 shows 3 other pipes, again with 10 inches offsets and 2 inches spacing, but the layout for the offsets on each pipe have been adjusted so the ends of pipes are now even. Note. In figure 8 to 2 you can see a mark was placed on each pipe 12 inches from the end of the pipe. This mark is used to illustrate the adjustment that must be made to pipes 2 and 3 if the ends of the pipes are to be even, while maintaining 2 inches spacing. The amount of adjustment needed to make the pipes even at the bottom is found by using the following offset adjustment formula. Adjustment equals center to center spacing x tangent of 1/2 the offset angle. Example. The pipes will be labeled A, B, and C from left to right, as shown in figure 8 to 3. First, bend a 10 inches offset in pipe A using 45 degrees bends starting at bend mark A, which is 12 inches from the end of the pipe. Using 45 degrees bends, the spacing between bend mark A and B 10 inches by 1.414 equals 14.14 or tilde 14 1/4, as shown in figure 8 to 4. Using 2 inches spacing, calculate the center to center measurement between pipes A and B, as shown in figure 8 to 3. The outside diameter of 1/2 EMT is 0.706, as shown in figure 8 to 3, so the center to center measurement with 2 inches spacing will be 2.706. 0.706 plus 2.0 inches equals 2.706. The offset adjustment formula says to multiply the center to center measurement times the tangent of 1/2, the offset angle. The offset is being bent using 45 degrees bends. 1/2 of the offset angle of 45 degrees would be 22½ degrees. The tangent for 22½ degrees is equals 0.4143. Multiplying 2.706 times 0.4143 equals 1.121, or equals 1/8, 2. The value 1 1/8 is the value that must be added to bend mark A of pipe B, for the pipes A and B to be even. The distance from the end of the pipe to bend mark A on pipe A was 12 inches, so 12 inches plus 1 1/8 equals 13 1/8. This is the measurement from the end of the pipe to bend mark A of pipe B, as shown in figure 8-4. 3. To find the adjustment needed for pipe C, we use the same formula as before, but the spacing used will be from pipe A, the first pipe, to pipe C. Referring to figure 8-3, we see that the center-to-center spacing between pipe A and pipe C is 5.41. This distance, 5.41 inches, times the tangent of 22.5 degrees, 0.4143, equals 2.241, or equals 2 1/4. 4. The value 2 1/4 is added to the 12 inches used for bend mark A of pipe C to give us a measurement of 14 1/4 for bend mark A of pipe C, as shown in figure 8-4. Note, the center-to-center spacing between pipes band C could also have been used. Referring to figure 8-3, we see the center-to-center spacing between pipe band C would be 0.353, plus 2, plus 0.353, which is equal to 2.706. This measurement times 1/2 the tangent of 22.5 degrees would be 1 1/8, 2.706, by 0.4143 is equals 1 1/8. The 1 1/8 is the adjustment that would be added to the 13 1/8, 1 1/8, plus 13 1/8, equals 14 1/4. Measure 14 1/4, from the end of pipe C to find bend mark A. Caution: making the adjustment as outlined to keep the ends of the pipe even will only work when the same size conduit is bent using the same bender or when different size pipes are bent using the same bender. 1/2 EMT can be bent on a 3/4 EMT bender as an example. Likewise, 1/2 rigid pipe can be bent on a 3/4 rigid bender. A 3/4 EMT bender can be used to bend a mix of 1/2 and 3/4 EMT to maintain the radius and spacing between the pipes, as shown in figure 8-5. The author has had little success trying to bend 1/2, 3/4, and 1 inch EMT with a 1 inch EMT bender. However, rigid pipe sizes 1/2, 3/4, and 1 inch can be successfully bent using the 1 inch shoe on a Chicago-style mechanical bender, as shown in figure 8-6. 1 1/4, 1 1/2, and 2 inches rigid pipes can be bent on a hydraulic bender using the 2 inches shoe and pivot supports. Use the rigid conduit spacing chart at the end of the book to determine center-to-center bend measurements for different size conduits. 4 bend saddles. 9. A 4 bend saddle is used to change elevation to clear an obstruction, just like an offset, but then to return to the original elevation, as shown in figure 9-1. A saddle, as you can see, is really just 2 offsets bent close together. As with offset bending, extreme care must be taken to properly align the pipe in the bender when bending a saddle. With a saddle requiring 4 bends, you double your chance of getting a dogleg, or a wow, which will require you to make adjustments to the pipe for it to be usable. If the misalignment is so bad it cannot be corrected, the pipe will end up in the OO pile as shown in figure 9-2. The old saying is, if you can screw up an offset, you can really screw up a 4 bend saddle. To bend a saddle, as shown in figure 9-1, 1. Measure the height and width of the obstruction. 2. Determine the spacing between bend marks A and B for the first offset, height of obstruction x offset multiplier. As all 4 bends of a saddle are bent at the same degree, the spacing from C to D will be the same as A to B. 3. Bend the first offset, bends A and B. 4. After the first 2 bends have been made, starting at a point where the conduit is straight after bend B, measure over the width of the obstruction and mark bend C. The spacing between bend marks C and 0 will be the same spacing as between bend marks A and B. 5. Figure 9-3 shows the bending sequence marked I-4. Predetermining saddle location. Many electricians will bend a saddle and then cut the pipe at one end or the other to make it fit, rather than learning how to predetermine the saddle location. This may be okay if you don't mind wasting material, or if you only bend EMT. When you're working with rigid pipe, however, the time it takes to cut and thread the pipe by hand after the bends have been made makes no sense whatever. A better way is to predetermine the saddle location, much like we did with offset in Chapter 7. The procedure for predetermining saddle location requires no new knowledge, but will require marking the conduit with a reference mark, or R. The reference mark, R, will indicate the location of the edge of the obstruction after the first 2 bends, first offset, of the saddle have been made. R then is the distance from the box to the obstruction plus shrink for 1 offset, as shown in figure 9-4. R will move to the left and be at the edge of the obstruction after the first offset of the saddle is bent. With R locating the edge of the obstruction, It can be used as a valid reference point for laying out the second offset, bend C and D, of the saddle. Predetermining offset location using method number 1 or number 2 from Chapter 7 can now be used to locate the first offset of the saddle. Method number 1 for predetermining saddles. Example. A beam 8 inches high and 10 inches wide is located 32 from the box, as shown in figure 9-5. The saddle will be bent using 1/2 EMT and 45 degrees bends. To locate the bend marks for the saddle, 1. Find the location for bend mark A by adding the height of the obstruction, 8 inches, to the 45 degrees offset constant for 1/2 EMT, 5 inches, and subtract this value, 13, from the distance from the obstruction to the box, 32 inches, for a value of 19. Measure 19 inches from the end of the conduit and mark bend mark A, as shown in figure 9-6. Note. Make all marks, A, B, R, C, and D go completely around the conduit so they will be visible when the conduit is rotated. 2. Determine the spacing between bend marks A and B, which will also be the spacing between bend marks C and D. Multiply the height of the obstruction, 8 inches, time the 45 degrees offset multiplier, 1.414, for spacing of 11.312, or equals 11/3/8, after we round up to the next closest, as shown in figure 9-6. 3. To locate R, we need to know the shrink for an 8 inches offset. The shrink for a 45 degrees offset is 3/8 per inch of rise. Multiply 8 inches times, equals 24/8, or 3 inches of shrink. Add the shrink, 3 inches, to the distance from the box to the obstruction, 32 inches, for a total of 35. Measure 35, from the end of the pipe and mark R, as shown in figure 9-6. 4. As R locates the edge of the obstruction, all that is needed to find bend mark C is to measure over from R, the width of the obstruction, 10, and mark C, as shown in figure 9-6. Remember that R will be at the edge of the obstruction where the first offset has been bent. 5. Measure 11 3/8 from bend mark C and mark D, as shown in figure 9-6. The spacing between C and D is the same as A and B. The conduit bending sequence will be A, B, C and D, as shown in figure 9-7. All bends will be made facing the end of the pipe that the measurements were taken from. Method number 2 for predetermining saddles. Method number 2 will use shrink to locate bend mark A. Bend mark A will be like R in method number 1. This method will require that the bends be done in a different sequence than method number 1. The pipe layout will be the same as in figure 9-5. The height of the obstruction in 8. The obstruction is 10 inches wide and it is 32 inches from the box to the edge of the obstruction. 1. Find shrink. Shrink equals height, 8 inches, x shrink value for 45 degrees. 8 inches by 3/8 equals 24/8, or 3 inches of shrink. 2. Locate bend mark A, which is also a reference to the front edge of the obstruction. Distance, 32 inches, plus shrink, 3 inches, or 32 inches plus 3, equals 35. Measure 35, from end of pipe to bend mark A, as shown in figure 9-8. 3. Determine spacing between bend mark A and B, same as C and D. Height, 8 inches, times the offset multiplier for 45 degrees, 1.414. 8 inches by 1.414 equals 11.312, rounded to 11 3/8. Measure 11 3/8, from A and mark B, as shown in figure 9-8. 4. Locate bend mark C from bend mark A, measure over the width of the obstruction, 10, and mark C, as shown in figure 9-8. Remember that A is the same as R, and is a reference to the front of the obstruction. 5. From bend mark C, measure 11 3/8, to locate bend mark D, as shown in figure 9-8. Spacing is the same as A to B. The bending sequence required for bending a 4-bend saddle using method number 2 is important if the saddle is going to fit properly. With your back to the end of the pipe that the measurements were taken from, place the arrow of the bender on bend mark A and bend to 45 degrees, as shown in figure 9-9. Note: bend mark A must be the first bend made for method number 2 to work. With your back still to the end of the pipe you measured from, rotate the pipe 180 degrees, place the arrow of the bender on bend mark B and bend to 45 degrees bend. Remove the bender from the pipe. Now face the end of the pipe you measured from, and place the bender on the pipe. Place the arrow of the bender on bend mark C and bend 45 degrees, roll the pipe 180 degrees and bend another 45 degrees bend at bend mark D, as shown in figure 9 to 9. 3 bend saddles 10. As the name implies, this saddle requires only 3 bends. This type of saddle is used primarily to go over pipes, ductwork, or other round obstructions, as shown in figure 10 to 1. While a 3-bend saddle can be bent using various angles of bends, the most common 3-bend saddle is made using 145 degrees bend, A, and 222.5 degrees bends, 8 and C. Notice in figure 10 to 1 that bend mark A, the 45 degrees bend, is centered on the obstruction, and that bend mark A also indicates the center of the 45 degrees bend. Most benders have a spot marked on the bending shoe that is used to indicate the enter of bend. If your bender does not have a dedicated mark, proceed as follows. 1. Mark a scrap piece of pipe, place the arrow on the mark and bend a 45 degrees bend. 2. Take the pipe out of the bender and mark the center of the bend. 3. Put the pipe back in the bender and line the arrow up with the original bend mark. Make a mark on the bender shoe that corresponds to the mark at the center of the bend, as shown in figure 10 to 2. This is the mark that will be used for bending the 45 degrees bend of the 3-bend saddle, not the arrow. Tip: once you have bent a few 45 degrees bends and double-check the center of bend mark, use a hacksaw and make a small cut on the bender shoe. This will give you a permanent reference, even if your original mark is rubbed off. Bend marks band C of the 3-bend saddle are 22.5 degrees bends, and are located equal distance from bend mark A. Band C will be bent using the arrow on the bender, not the mark we just put on the bender to indicate center of bend. To determine the spacing from A to B, and A to C, we simply multiply the height of the obstruction times 2.5. The multiplier of 2.5 is used for all pipe sizes when bending 45 degrees and 22.5 degrees bends. Example: lay out a 3-bend saddle using Y1/2 EMT to clear a pipe with an 8 inches outside diameter using a 45 degrees and 222.5 degrees as shown in figure 10 to 3. 1. Determine the spacing from mark A to B and A to C. Spacing equals 2.5x height, 8 inches. 2.5 by 8 inches equals 20. Spacing from A to B, and A to C, will be 20 inches. 2. Bend mark A is placed at the approximate center of the conduit. Mark band C are marked 20 inches either side of bend mark A, as shown in figure 10 to 4. 3. Bend the 45 degrees bend at bend mark A first using the center of bend mark, as shown in figure 10 to 5, not the arrow. 4. The bender is removed from the pipe and repositioned so that both bends band C are made facing bend A, as shown in figure 10 to 5. Bends band C are bent to 22.5 degrees using the arrow on the bender. 5. Cut the end of the pipe as may be required for the offset to fit correctly at the obstruction. Tip: if the EMT bender you are using is the type that the bender handle is perpendicular, vertical, to the work surface when a 45 degrees bend has been achieved, then for the two 22.5 degrees bends, invert the bender, placing the handle vertical width to the floor, work surface, as shown in figure 10 to 6. If the pipe were now to be bent to 45 degrees, the pipe would end up being horizontal to the work surface, as shown in figure 10 to 6. It follows then, that if we bend halfway we should have approximately a 22.5 degrees bend. Bend a few trial bends measuring your results with a protractor level. It won't take long before you can produce good results using this method. For the 3-bend saddle to look right when it crosses over, traverses, a round obstruction, the radius of the 45 degrees bend must be large enough to fit over the obstruction, without touching the obstruction. The maximum diameter of a pipe, or round obstruction, that can be crossed will be limited to the radius of the bender shoe for any given pipe size. The larger the conduit, the larger the radius of the bending shoe, therefore, the larger the diameter of the obstruction can be. Table 10 to 7 gives the approximate maximum diameter of the obstruction for 1/2, 3/4, and 1 inch EMT being bent with a hand bender. The maximum obstruction diameter for larger EMT pipe sizes bent using electric or mechanical benders can be determined by bending scrap pipe. If it is more desirable to bend all 3 bends facing the same direction, it can be done by using a multiplier of 3, instead of 2.5, and bending all the bends A, B, and C using the mark on the bender that represents the center of the bend. Note: this method can be used for hand benders and is the recommended method for Chicago-style benders. Example: lay out a 3-bend saddle to clear an 8 inches pipe, as shown in figure 10 to 8. 1. Determine the spacing from bend A to B and A to C. Spacing equals 3x height, 8 inches. Spacing equals 24. 2. Bend mark A is placed at the approximate center of the conduit. 3. Locate marks band C at 24, either side of bend mark A4. Bend all bend using the center of bend indicating mark, not the arrow. Bend all three bends facing the same end of the pipe, as shown in figure 10-9. Predetermining 3-bend saddle location. Using shrink. To save cutting pipe to make the 3-bend saddle fit, the center of the saddle, center of obstruction, can be predetermined by adding shrink to the distance required. The 3-bend saddle requires one 45 degrees bend and two 22.5 degrees bends. As the two 22.5 degrees bends total 45 degrees, the 3 bends 22.5 degrees, 45 degrees and 22.5 degrees are the equivalent of two 45 degrees offset bends, so the 45 degrees offset shrink of per inch of rise can be used. See table 7-21. The total shrink for an 8 inches saddle will be 8 inches by 3/8 equals 24/8 or 3. The way the bends are made, both ends of the conduit will shrink in relation to bend mark A, a total of 3. Each end of the pipe then will shrink 1/2 of 3 inches, or 1.5, as shown in figure 10-10. As we are only concerned with locating the center of the bend from one end of the conduit, 1/2 of the total shrink will be used for prepositioning the saddle location. Example. Lay out the bend marks for a 3-bend saddle to clear a 6 inches pipe. The box is located 30 from the center of the pipe, as shown in figure 10-11. A multiplier of 2.5 and 3 will be explained. 1. Find the total shrink of the pipe. 6 inches by 3/8 equals 18/8 or 2.25 total shrink. 2. Locate bend mark A distance from box to center of pipe, 30 inches, plus 1/2 shrink. 1/2 of 2.25 is 1 1/8. 30 inches plus 1 1/8 equals 31 1/8. Measure 31 1/8 from end of pipe and mark bend mark A as shown in figure 10-12. 3. Determine spacing from A to B and A to C using 2.5 as a multiplier. 2.5 by 6 inches equals 15, spacing equals 15. 4. Locate bend marks band C as either side of bend mark A, as shown in figure 10-12. 5. Bend a 450 bend at mark A using the center of bend mark on the bender. Bend 22.5 degrees bends at bend marks band C using the arrow as a reference as shown in figure 10-5, and facing bend mark A. If it is more desirable to bend all 3 bends facing the same direction, it can be done using a multiplier of 3 and by bending all bends, A, B, and C, using the mark on the bender that represents the center of bend. Note: this method can be used for hand benders and is the recommend method to use for Chicago-type benders and hydraulic benders. To find the spacing using a multiplier of 3 for the previous example, 1. Spacing equals 3x height, 6 inches. Spacing equals 18. 2. Locate marks band C18, either side of bend mark A, as shown in figure 10-12. 3. Using the center of bend mark on the bender, bend at bend mark B, 22.5 degrees, then bend mark A, 45 degrees, and then at bend mark C, 22.5 degrees. All 3 bends are made facing the same direction, facing the end the measurements were taken from, as shown in figure 10-9. Problems. Preposition the saddles shown in 1 and 2, using a multiplier of 2.5, to locate bend marks A, band C. Preposition the saddles shown in 3 and 4, using a multiplier of 3, to locate bend marks A, band C. Bending around a corner with an obstruction 11. Although this is not a common bending job, it is one that can become very frustrating if the proper method is not known. The examples that follow are the most common types of obstructions that are encountered. In each case, to go around the comber and the obstruction, the pipe is bent using two 45 degrees bends. For each type of obstruction illustrated, a formula is given to determine the spacing between bend marks A and B. Round obstruction. Figure 11-1 shows a round obstruction in a comber and gives the formula. Spacing equals D by 2.4. D is the diameter of the obstruction. 2.4 is a constant that is used regardless of pipe size when bending 45 degrees bends. Spacing is the spacing between the two 45 degrees bends. If the pipe in figure 11-1 is 6 in diameter, the spacing between the bend marks is found as follows. Substitute values into the formula and solve. Spacing equals D by 2.4. Spacing equals 6 by 2.4. Spacing equals 14.4 or equals 14 1/2, rounded up to the next, as shown in figure 11-2. The arrow of the bender is placed on the bend marks as indicated in figure 11-3. A 45 degrees bend is made at bend mark A and bend mark B with the bender facing the same direction. Square obstruction. The next example is a square obstruction, as shown in figure 11-4. The formula for this type of obstruction is spacing equals dx3 when bending 45 degrees bends. If the dimension of the square obstruction was 8 inches by 8 inches, the spacing between bend marks A and B can be found as follows. Substitute value in the formula and solve. Spacing equals dx3. Spacing equals 8 by 3. Spacing equals 24, as shown in figure 11-5. Rectangular obstruction. In the next example, the obstruction in the corner is rectangular, as shown in figure 11-6. The formula to find the spacing between bend mark A and B when bending 45 degrees bends is spacing equals d plus d squared by 1.414. The rectangle in the corner measures 6 inches by 8. To determine the spacing between A and B, substitute values into the formula and solve. Spacing equals d plus d squared by 1.414. Spacing equals 6 plus 8 inches by 1.414. Spacing equals 14 inches by 1.414. Spacing equals 19.796 or equals 19 7/8, as shown in figure 11-7. If the obstruction is square as shown in figure 11-8, the rectangular obstruction formula can be used. The square shown in the comber measures 8 inches by 8. To determine the spacing between A and B, substitute values into the formula and solve. Spacing equals d plus d squared by 1.414. Spacing equals 8 plus 8 inches by 1.414. Spacing equals 16 inches by 1.414. Spacing equals 22.624 or equals 22 5/8, as shown in figure 11-8. Note: all of the formulas discussed in the layouts may be used with Chicago-style benders. Predetermining bend marks. Round obstructions. To find bend mark A for the round obstruction shown in figure 11-9, the formula is bend mark A equals distance, d by 0.68 plus 1/2 the offset constant for 45 degrees. Distance is the distance from the box or conduit fitting to the obstruction. In figure 11-6, the distance is shown as 36. D is the diameter of the obstruction and is 4 inches as shown in figure 11-8.68 is a constant use for all pipe sizes. 1/2 the offset constant is 1/2 the value found in table 7-12 if the pipe is 1/2, 3/4, or 1 inch EMT. If you are using rigid conduit or EMT larger than 1 inch, use half the value you have determined to be the offset constant for the type and size of pipe you are using. Figure 11-8 indicates that the pipe size is YO, EMT. The offset constant for 1/2, EMT would be 5. 1/2 of 5 inches is 2.5. Substitute values and solve. Bend mark A equals 36 inches, 4 inches by 0.68 plus 2.5. Bend mark A equals 36 inches, 5.22. Bend mark A equals 30.78 or tilde 30 7/8. If rounded to the next, as shown in figure 11-10. Spacing from A to bend mark B is found by using the formula. Spacing equals d by 2.4. Spacing equals 4 inches by 2.4 equals 9.6 or equals 9 5/8. Spacing between A and B, as shown in figure 11-10. Predetermining bend marks. Square obstruction. To find bend mark A for the square obstruction shown in figure 11-11, the formula is bend mark A equals distance, d by 1.4 plus 1/2 the offset constant for 45 degrees. This pipe job is using 3/4 EMT with an offset constant of 6 1/4. 1/2 of the offset constant would be 3 1/8. Substitute values and solve. Bend mark A equals 36 inches, 6 inches by 1.4 plus 3 1/8. Bend mark A equals 36 inches 11.525. Bend mark A equals 24.475 or equals 24 1/2, as shown in figure 11-12. Spacing from A to bend mark B is found by using the formula. Spacing equals dx3.